Welcome. My name is Daniel Roy Greenfeld, and this is the No Holds Barred Web Framework Battle. So first of all, thank you, Calvin and Darcy and Carol and everyone with the Python Web Conference. I've run events before. One of the things I want to mention is that what you see, the seamless, beautiful experience that you are having at the event, that's not really what's happening behind the scenes. There's always emergencies and drama behind the scenes, and it's a testament to the Python WebConf team, just how smoothly this is running and how elegant this is. And I love of course, I love the logo and stuff. You can see me wearing the shirt with my epic beard, and I wish I was wearing the shirt, but I had a spill right before this event, so hence why I'm wearing a work hoodie. But anyway, the point is thank you for having me, and let's get started. Oops, that's a duplicate slide. Okay, so about this talk, I'm going to compare some web frameworks, and I'm going to do it based off of my opinions and preferences. And these may not be your preferences. You may disagree. And I bring this up because I have to address the question of bias. Because you see, a lot of people think of me as that Django guy. I mean, there's merit to that. But really, my nickname is PyDanny. I think of myself much more of a Python developer than a Django developer. However, as Calvin mentioned, there's been some books along the way. And so I have written 2 books, a total of 6 editions between them about Django. On my personal site, I have over 200 articles tagged with Django in it. I can't tell you how many open source contributions I've made to the Django ecosystem. And there's been oodles of production projects that I've helped in some capacity or deployed. And if you compare that to the combined FastAPI, Flask, and Pyramid world, I think I have 16 articles on my sites tagged with the 3 of those frameworks, and I've been involved in about 15 production projects. So I can understand the concern about bias. However, I want to bring up Zope and Plone, which Calvin mentioned. On my site, I have 74 articles tagged with Plone, 38 for Zope, and 2 production projects. And I bring that up because I have a tendency to write about what I'm being paid to work on. Not necessarily what I prefer to do, but what I'm paid to do. So yes, I have about Django, but I can also make the counter argument that all that experience about Django gives me the ability to write about or discuss the pain points of it. Also, additionally, I've used Flask for over 10 years, FastAPI for 3 years. As soon as I heard it about it, I tried it out. I did Zope and Plone for 4 years at NASA, and I used Pyramid and its predecessors for over 17 years. In fact, when I was first doing Python professionally, I was working with one of the frameworks I was using was Pylons, which is one of Pyramid's great-grandfathers. Calvin, I'm sure, can explain the lineage there. And I've even, in Tornado a little bit, and I mentioned that because I like Tornado. So which frameworks am I covering in this? There's the Django and FastAPI and Flask, most of you will know. There's also Pyramid, which is an awesome micro framework with some really neat features that I really like. And finally, there's Tornado, whose async model just clicks with me really well. However, when I was creating this talk, I realized I couldn't include Pyramid and Tornado. There's just too much material. And Django and FastAPI and Flask, for better or for worse, are at least an order of magnitude more popular and more in usage than the others. Even though Tornado is the backbone of Jupyter Notebook, besides that, it's not commonly used. I do want to mention that I like all the 3 frameworks that I'm comparing. Every one of them, you can absolutely win and build amazing projects. Patreon, for example, is powered by Flask. And Django, Octopus Energy, we use Django. We also, of course, use FastAPI and Flask. But the point is you can build anything from small projects that work really well to giant unicorns that bring in billions of dollars. the framework helps, but it's not really what matters. What really matters is the implementation. And finally, because I am going to say some negative things about all three frameworks, I have to give a lot of credit to the authors, the creators, and the contributors of them. They've done an amazing job. Building a web framework is not for the timid. It's an advanced topic if you are doing anything besides a toy. So thank you. I could spend this whole talk just crediting the people who've worked on it. They are my heroes. Okay, let's dive in now that we're past the preview or the intro. So first, I'm going to give a quick intro of the frameworks. Django is it was released about 18 years ago. It's a full stack framework, which means that it handles serving of pages and APIs. It handles your database for you, does HTML generation, a ton of stuff. It's bundled with ORM and form validation. It has this wickedly awesome admin tool built in, which I know that there's analogs in FastAPI and Flask, but the Django admin has so many more features than those. It is larger than the other frameworks because of all these features, which means that that will affect the ratings, and you'll see that in minutes to come. FastAPI is about 5 years old. It is almost a micro framework. I say it isn't one because it comes bundled with validation of incoming data through the awesome Pydantic library. It uses type annotations to define behaviors, which makes certain elements of it really intuitive and elegant. And it is async from the absolute beginning, which, like Django's bottom point, affects the ratings. And Flask, it was released as an April Fool's Day joke about 13 years ago. It was an epic joke. If you want to take the time to look it up and read about it, I was there when it unfolded, so was a bunch of you, and yeah, well done. It is truly a micro framework, which means it has a tiny, tiny core. However, there is a decently sized community of extensions and libraries that go with it. You will see that a lot of tutorials by SaaS vendors and API vendors where they need something accepting, webhooks and stuff like that, will use Flask as a tutorial. You also see it for how to deploy on various platforms as a services, and that is because the absolute simplicity of Flask at the basic level makes it really easy to write tutorials based off of it. The things I'm going to compare today are developer experience, how fast something goes or speed, the support for asynchronous databases or persistence, and then sweet spots. And I'll go into a little bit more detail when we get to each one of those items. Okay, so we are going to start with developer experience. We're going to cover in this segment, getting started, data validation, small projects and large projects, how it deals with both size efforts. Okay, developer experience, getting started. How fast can someone, be it a beginner or a senior engineer, take the framework and start building stuff and getting things done? If we look at the basic code examples, FastAPI and Flask share a very similar design. And FastAPI, well, it looks a lot like Flask at this level. As soon as you start really doing real development, it'll look really different. Like these are toy projects, but anything more complicated than this, you'll see it'll drift from the patterns that Flask popularized. Flask is this is the design that was created by Daniel Lindsley, I think like 14 or 15 years ago. He copied Ruby's Sinatra thing into a project called IDI, and then that pattern was taken by Bottle, which is another micro framework, and then Flask, of course, made this pattern super popular. And you can see it's really easy to get started. I would say, like, if you go on GitHub and look for people's starter projects, like beginning engineers, about 50% of them will be something similar to this Flask example. Django, this is not covering a bunch of the configuration that has to happen. There is no quick start in Django. You can build Django apps as a single page app if you really know what you're doing, but no one does that. Getting a little bit more into details and nuance, Flask wins here, hands down. And the reason is documentation. Flask Quick Start is amazing. It is an exercise in concise delivery of information. It covers everything that you need. It is arguably a cheat sheet. And I would estimate 80 to 90% of Flask projects, that people have on GitHub or building for personal stuff, most of the materials coming out of the Quick Start. That is how awesome it is. And Flask, to the people in Flask who put this together, as someone who in my professional writing, like for 2 Scoops of Django and stuff like that, I have mad respect for this Quick Start. It's just, because as an author, I try to make things super concise, and Flask super delivers on this. FastAPI is kind of mixed results. Well, it's easy to get started. You can copy a code example. The Quick Start needs work. It's more of a display of features and references to what kind of value, like what type of HTTP methods that you can have, than stuff that's actually useful for developers who are trying to get started. And in Django, let's face it, there is no such thing as a quick start in Django. And whether or not the tutorial is good or not, I like it. The core tutorial or the Django Girls tutorial, building a Django project, even a toy project, takes time and understanding of the framework to really get started. So for this one, I'm going to give it to Flask. Congratulations, Flask, for winning this segment of developer experience. Well done. Okay, so moving on. Next one is incoming of data validation. And what this is let's say you are accepting input from users, or even you're picking up files and data from files like a CSV. How do you validate that data? What kind of tooling does the framework provide? Django and FastAPI both come in with built-in validation, and I like both of them. They both are pretty easy to learn, and they both work. And as you know, I've used them for years now. Flask comes with no built-in validation. It is a micro framework. The real and I'm okay with that. However, the real problem I have with Flask is that there's no mention of telling developers learning Flask to validate their incoming data. And while there's an incredible library called Flask WTF, which is built around the WTF library, except for one link, there's no mention in the core docs. And I think that's a problem, because in a lot of cases, Flask is the first framework that new developers use. So unfortunately, I'm going to ding Flask on that. Digging in a little bit more and comparing Django and FastAPI's incoming, the data validation, I give the slight edge to FastAPI. And it's, it's not because of that I find the type annotations for defining pydantic models so elegant, and that is true. I do find Django, I can, like the forms framework, I can spin it and make it do more creative things. Where I think FastAPI just barely gets the win is that it forces you to validate incoming data. You can get around that, but it takes a lot of work. Whereas with Django, you're not forced to validate that data. And why this matters, especially now, is with the advent of YouTube, anyone can make a tutorial, and that's great. However, what we're seeing is people who learn from YouTube copying each other and creating their own tutorials. And while I do enjoy that and love watching this new breed of people, new developers doing this, the challenge is that a lot of them learned from someone who said, hey, I'm not sure who it is, who hit the request.post and request.objects directly and started injecting it into their database. And that's a mistake. And that's because Django doesn't force it on you. So the winner that I'm going to get just barely is FastAPI. So good job, FastAPI, for forcing people to validate data. Someone who cares about data integrity and security, this does make me happy. Okay, small projects. Which one of these projects is good for, or frameworks is good for small projects? So FastAPI takes the lead a little bit here. While Flask is close, the top three bullets are identical. They're both light and easy to get started. You can do one file apps, and the flexibility of databases or not having a database is a virtue. The downside, the advantage that FastAPI has is the built-in validation that comes with it. And then as someone who loves the REST API, the fact is that, you know, I get Swagger or OpenAPI documentation for free. That's where you go on, and Django REST framework provides this too. But in FastAPI, it's built in and it's really elegant and easy to use. In Flask, well, there's some libraries to do it. They don't seem to compare, for me at least, to what FastAPI provides. I don't want to count Django out, however, because Django comes with the fantastic admin tool, which is great for if you're running the SQL, which is what you should on Django. And what this means is that you're not having to like figure out how to check records or make sure that the values are correct. It is overkill if you have a project without an SQL database or even no database. And if you do want to do a single file app, you can do it. I've done it, but it does require advanced knowledge, and it's really rare for actually someone to deploy something into a meaningful production project. So the winner for this is Flask, not Flask, FastAPI. Okay, let's get into large projects. This is like the big boys, or big boys and girls. And of course, Octopus is a large project. And so Octopus or the framework, the repo and project that we have is called Kraken, is powered by Django. And the reason why I was chosen for this is because Django was originally extracted from a large project, and Django is designed, I think, is really designed around building large projects. The app component architecture that we use in Django, that most of you should be probably are familiar with, it's described in the core tutorial, it's described across the project. And this core app component infrastructure, even if you take a service layer approach in Django, you're still using the app system. And it basically is where one little component or app has its own views and models and logic. It's borrowed from the POSIX philosophy of, each component should do one thing and do it well. And it is, in addition to just making it it forces us to have a structure for our projects. It also allows us to have a really vibrant and dynamic ecosystem. And so that means it's just easier to find things doing items that you might need in Django than you might find in Flask and FastAPI. So I'll give this one to Django. Flask does have something similar to apps called blueprints. It's somewhat similar, and I like the approach. The challenge that I have with Flask and blueprints is that I rarely see it in decent sized Flask projects. I'd say about 90% of the ones I've encountered end up being, maybe they take a service layer approach, but typically they're like big balls of mud, and that's unfortunate. But it is what I've experienced. I haven't seen some well-architected Flask apps, but again, those are the exceptions rather than the norm. FastAPI gives us nothing in terms of documentation on how to accommodate large projects. And there's nothing like blueprints or apps for FastAPI. But FastAPI, it's not entirely bad because the design of it encourages separation of concerns over time. So if you know what you're doing, if you do have a decent body of experience building web, not just web projects, but Python projects, you can work with that. But again, Django, I think, really cleans up here. So the winner here for large projects and developer experience is going to be Django. Now, to summarize, if we look at the total number of green emoji check marks, and we just do some really simple math, FastAPI does take the lead here. It just wins on data validation, small projects, and Django and Flask, well, they do have their special areas. FastAPI is going to be the winner of the aggregate developer experience. So good job, FastAPI. I'm just gonna drink some water. Okay, speed. How fast does a project go? Look, because we like to travel fast. But before we get into benchmarks and metrics, I do want to raise that typically with web projects, web applications, it's usually the database that is the bottleneck. And the correction for it isn't usually making changes to the framework. Often it is about exploring indexes and caching. Indexes are supported by every database that I'm sure people touch on here, and that includes relational databases, that's SQL, DynamoDB, MongoDB, Firebase, FaunaDB. The list goes on and on. The thing is that fixing indexes, addressing whether or not your indexes make sense, is a more effective way to improve the speed of a project than trying to switch frameworks. And it's also going to be a lot less work and less error prone. Also, if you caching, which is where you store results in an ephemeral store like Redis or Mcached, is another way to increase performance. And that is a better place to try to speed things up than change out a framework or mix and match components of frameworks. Also, there's the fact that, playing with statistics, you can get different results depending on what you're trying to achieve. And different benchmarks will use different tools and methodologies. The result of this, sometimes when people create these benchmarks, they may make mistakes on it and how they create these benchmark tests and generate results which are misleading. Sometimes it can be accidental, and in some cases it can be intentional because people may or may not have agendas. And the classic example is in the early Tech Empower benchmarks, and I'm going to cover Tech Empower in a second. Django was compared with its ORM and hitting a database with Flask and FastAPI with no database access. So it doesn't matter how fast Django is, if it's hitting the database, it's going to be slower than its competitors. They've addressed that to as much as they can, but just understand that when you're talking about benchmarks, you always have to take it with a grain of salt. But let's see how things perform. Which one goes fastest with JSON serialization. And the request that the test that was constructed, what it does, it just hammers an application server asking for hello world, or it's pinging it and it's getting a response of hello world. And it's super simple, straightforward. And with this, not surprisingly, FastAPI, which was designed from the ground up to serialize JSON, wins. Out of about 500 frameworks reviewed and framework combinations, it is in position 305, which is great. And Django got 356, which is respectable. What really shocked me, though, was that Flask was at 444. Now, between you and me, I'm pretty sure that Flask should be between FastAPI and Django. In fact, I think it should be really close to FastAPI in speed. Nevertheless, this is what the benchmark had. Sure, this has been raised in discussion areas and stuff like that, but it's really important to observe this because it is indicative of the fact that we have to take these benchmarks with a grain of salt. Moving on to fortunes, and what the fortunes test is this is where the database is created with 12 records of it of different fortune cookie messages. The framework is then hit with a request to say, hey, can you insert into this list, sort that, and then deliver it back in a server-side HTML template. And the template is to be properly escaped. And so that way, in case there's the ideas that we're saving the output. White space is optional and can, it depends on what the framework likes. And you can see there's an example request at the bottom of the page. Once again, the results were a bit curious. FastAPI won, which is great for FastAPI. And then Flask, if you're writing raw SQL, it beats Django. Flask is rated at 319, whereas Django is 384. So good job, Flask. And this makes a little bit more sense. It's not that far off in a group of 500 from FastAPI, so it's kind of expected. What's really surprising, though, to me is that with the ORM that was chosen, which was SQL Alchemy, Flask is running slower than Django. And between you and me, this is not accurate. There's no way. I mean, if you've ever played around with Flask and SQL Alchemy, you just know that it is faster than Django. And I'm not saying Django is slow. I'm just saying that Flask plus SQL Alchemy is faster. So again, I think there's something wrong with the benchmark, but it is what we have to work with. So, I'm going to say that Flask is in between FastAPI and Django. Okay, composite. By composite, what this is where there's about 10 tests on the Tech Empower website, and this is where they combined all the scores and rated them. And here, if you look at the values, Flask actually wins. And if you look at the tests carefully, you can see they're a mix of a lot of queries with templates. And in this, which unsurprisingly, Flask did well. FastAPI did respectable. It came close to Flask. And this to me, and Django, of course, is last. This to me is a more accurate representation of a test that I think is the methodology and tools were executed well. So I did like that, or I did appreciate that Flask is where it should be in the test compared to the previous two examples. And the thing is this is a question of apples and oranges that, well, and a lot of this does make sense that FastAPI is fast. So JSON serialization is designed to handle it fast. And then Flask, because it's a micro framework that is really good with, light, easy tasks, or not, I wouldn't call them easy. Nothing is easy in tech, but it's better with light and varying tasks. It has a good composite score. And Django, of course, as is proper, just because it has more code into it, significantly larger than its competitors, it's running slower. I will mention, though, that if you take out the middleware and context processors and a bunch of other features that typically come bundled in with Django, and you can do this by messing around the settings file, and then you run tests, it will run at speeds comparable to Flask and FastAPI. Again, the concept of lies, damn lies, and statistics, and that we have to take this with a grain of salt, comes to mind, that Django is just simply bigger and slower and heavier. So in summary, and you can see I'm linking to the Tech Empower benchmarks here, FastAPI and Flask are just faster. One thing I do want to mention is that FastAPI is far and away the fastest if you get into asynchronous coding, if that is a requirement. And FastAPI is about to get a speed boost with the advent of Pydantic 2.0, which has a Rust-powered backend. So for form validation, the form validation is going to be 8 to 10 times faster. So that's going to be a significant boost for FastAPI, at least with the acceptance of data. Django, again, it's just slow. So I'm going to give this as a tie to Flask and FastAPI. I think that is I know that in the FastAPI world, they say that they're the fastest. I think honestly, if we take a more objective view of the tests, and no offense, Sebastian, but this is what I've observed in the wild. Okay, moving on to asynchronous support. Why does asynchronous support matter? Why do we care? Well, if you want to serve WebSockets from your servers, you need to do that with an asynchronous server. And if you're playing around with blocking input and output, you want an asynchronous server. So if you're streaming files or dealing with slow APIs and tar pits, async is the way to go. And for some of you may not know what a tar pit is, and I'll explain what that is. A tar pit is, let's say, for example, we build an application where on our page, we display the weather up there on the corner. And each time a visitor comes to the site, what we do is we hit a weather service API and we get the information we display. We don't cache it, we're just pulling it each time. And one day that service slows down. Well, if we're running things asynchronous, that means that if we do things right, the user doesn't see the slowdown. They may see the data from the the API come up slower, but the delivery of the page isn't going to slow. If that API starts to hang, like you send a request and it doesn't return anything for minutes at a time, then it's not a slow API. It is what is called a tar pit. And tar pits are really, really dangerous. It's why you don't do this. You don't hit external APIs per page request with a synchronous thing. You either do things with an asynchronous server, or you send off a request using async task queue like Celery, and you cache it locally. Because what happens is each request from a user that goes out to the external system consumes a thread. It like holds onto it. And then if the tar pit doesn't let it go, then that application server runs out of things. And if it's just like on local development, it's not going to matter. But in production, if you have 100,000 users hitting your system and they consume 100,000 threads and are waiting for that response, and then they start hitting refreshing for refreshes, and you go from 100,000 threads consumed to millions, your application server is going to crash and your hardware is going to crash. So it's a serious, serious problem. So this is why async can absolutely matter. So for this, FastAPI wins. And the reason why is because from the beginning, it was designed to support async. And on top of that, because of that, it has good documentation around it, and it's easy even for beginners to develop asynchronous projects. Even if they don't use any of the features are basically running a synchronous project, but they've just defined their functions as async def. It's easy to do. In comparison, Django, well, there's been this Herculean effort led mostly by Andrew Godwin for the past 10 years to bring async into Django. It's not for beginners, and the docs cover the fundamentals and not much else. There's some neat features like the sync to async decorator, which is useful because the ecosystem is synchronous, or most of it is synchronous. Yeah, it's just not as elegant and good and useful as FastAPI. Flask also now supports asynchronous view methods or view functions, which is great, but it's slow, and they admit it in the documentation. So in fact, the Flask team has created Quart, which is kind of a drop-in replacement for Flask, which supports async. And however, the documentation for it is kind of like Django's. It doesn't really cover what you need. So you really need to know what you're doing in order to be able to do async effectively in Flask. And like Django's ecosystem, most of the Flask ecosystem doesn't support this behavior. So for async support, I'm going to give this one to FastAPI. Okay, next up is databases. How do we handle persistence of data? I'm going to explain the databases I like because these matter to me. And this is part of why I've used so many different frameworks. Of course, I love relational databases. Give me some Postgres. I prefer to work at, when we do SQL, I prefer to be at places that use Postgres. DynamoDB is another one that I really like. It's Amazon created it to support their shopping cart system, which means that there's odds are none of us in this call are ever going to build an application that needs more scaling up than Amazon shopping cart. So DynamoDB scales to infinity. If you understand how the single table design approach works, rather than trying to mimic relational databases, it's just really nice and fun to do, fun to use. In comparison, and then there's Firebase. I'm not comparing with them. Firebase is kind of like MongoDB that Google hosts in the cloud. I really like it for hackathons. Audrey and I have won some events with it. And yeah, there's something about Firebase just really clicks with me. And I'm going to make this a three-way tie. That's right. Django, from the ground up, it's designed for SQL databases. And sure, you use Redis and Cache for caching, but functionally you're building stuff in SQL. And this universality of SQL, because we know what the persistence layer is going to do, means that combined with the app component system, it means that Django has this amazing package ecosystem that I really enjoy, and Django Packages was created to support that. And of course, I do want to mention if you are trying to use NoSQL for your primary data store, like MongoDB or whatever, in Django, that's a mistake. Nothing against MongoDB. It's just not meant for Django, and I've written extensively about it. In comparison, Flask and FastAPI, you can use whatever you want, or you don't even need to use a database. The frameworks support both, and I have found great use in both of that, and both approaches with both frameworks. So this is a three-way tie, and I'm happy about that. So good job, teams. Okay, let's jump into sweet spots. Let's go over what it is about each one of these frameworks that really pulls me and makes me really happy working with them. Of these three, I would tie Django and FastAPI. Django is great on large projects. The admin, at django.contrib.admin, just so useful to be able to like have an interface into the database that matches the models that we've designed, rather than using, sure, you can use various views into databases. There's, desktop and web-based tools, but the admin is tied to the structure of the data that you're working with. The third-party package ecosystem is amazing in Django. That's where a lot of my open source contributions have gone. And then, excuse me, sorry. Recently in the past few years, I know there's Django REST framework, which is, I know people have built like big projects with it, but we've seen recently a return of going back to working entirely with templates becoming more and more popular. And this is with the rise of HTMX, where we can mimic single page apps by, instead of refreshing the whole page, we only refresh a small part of it. So it's a return to the old jQuery plus Ajax, but a more elegant and concise and performant way. And there's no trying to render JSON in the browser. It's just moving blocks of HTML back and forth. And it's really elegant. Django isn't the only framework where we see core team members have embraced this. The Rails community also has their own analogs to HTMX. And so I find working with this has really given me a new appreciation for Django. And so I'm really happy to see this development in the Django community. FastAPI, again, I love RESTful APIs, and I love how easy FastAPI makes it to build them. Actually, Django has a package called Django Ninja, which kind of mimics FastAPI, but FastAPI just makes it, I think, a little bit more elegant to work with. It's fantastic on small projects. The async model is really, really nice. I didn't think I could find something I liked more than Tornado until I ran into FastAPI. And then, of course, the elegant design of using type annotations to define behaviors and how things work is really intuitive. And so, yeah, so good job, both Django and FastAPI. And Flask, of course, remains good on small projects. I still have a Flask project running that has been going for, I think, something like 10 years, and it just works. So why change it? It's great. So the winner on sweet spots, what draws me in, is Django and FastAPI. So what do I use on new projects? If you ask me, hey, tomorrow we're starting X, what are you, and I want you on it, Danny, what are you going to use? Well, I want to remind everyone before I give my conclusion that all three frameworks are awesome. And while I'm at it, I'm going to mention that Pyramid 2 is awesome just because I have, respect for it. So you can win with any of them. There's no wrong answer in which one you're going to choose, or that I'm going to choose. However, for all that I have respect for them, there can only one framework that wins. And if we count up again green emoji check marks, we can see based off of our ratings that FastAPI just has a higher number than Django and Flask. It's simple math. It's 5 versus 2. So the grand winner of our contest is FastAPI. And for those of you who may be taking screenshots of this or looking, or I'm going to supply the slide afterward, I am putting the areas where I think FastAPI can improve. The quick start is it needs improvement. It is, again, it's a rough visit, a feature that can be improved. And also, again, there's no guidance on large projects. So if someone who doesn't have a significant body of experience starts using FastAPI, I'm concerned that they will, even though it encourages separation of concerns, I have concerns that they will build balls of mud, spaghetti code that'll be hard to debug. So those are areas that FastAPI can improve on. And both of these are, I believe, documentation issues rather than issues with the code within the project. And these, I will say though, that these are challenging areas to address. These are heavy projects to embark on. So a little bit about me. My name is Daniel Roy Greenfeld. I am a coder at Kraken Technologies, which is part of the Octopus Energy Group. I've written books. I love to code. I have led and continue to lead engineering teams. My wife is Audrey Roy Greenfeld. If you know what Cookiecutter is, or Pie Ladies, she is she was the creator of both, or a creator of both. And I have a little girl named Uma, and I am a superhero saving the planet. Speaking of which, are you looking for work that matters, that will help generations to come? Well, my employer, Octopus, or I work for a division of Octopus Energy called Kraken Technologies, is hiring, and it's an awesome place to work. I hope you consider joining me or other companies focused on decarbonization and addressing climate change. I know that that's been a theme of this conference, but if you are looking for work, we are hiring across the globe. So please join me in the battle against climate change. And again, even if you can't come to us because maybe you're in a country where we don't have a legal entity because we have to hire, we can only hire from places that have that. If you can't come and work for us, come and go and work for one of the other companies who have been here at the Python Web Conference, and join me in this quest. And if you do that, hit me up, let me know who you're working for, and I will sing your praises on social media, and I'll say wonderful things about you, because at the end of the day, I'm going to go back a few slides. I want the little girl in this photo to have the same planet that we grew up in, and we can do that together. Our tech talent is a superpower, right? We can spin code and make it do wonderful things, and I'd rather each and every one of you be working with me on decarbonization, and you can make money doing it rather than helping a billionaire make another $1 billion while not making any meaningful contributions to the future of us. And so this isn't just for my daughter, this is for your sons, your daughters, your nieces, your nephews. This is for their children and their children. So it's about us. It's about our descendants in the years to come. All right, any questions?
Beautiful talk. I love the way you ended it on that note. And you go work with Daniel, or go work with Daniel's competitors. I completely agree. That is the way to go. There are so many great companies who are here represented, and we should all go out there and make a difference. But I do have one question. One thing you didn't touch on in all of those comparisons was the community and the stability of the code base and how many people are contributing along the way. I think that might have tipped your scale a little bit.
Yeah, I thought about that, and actually I know what who you're digging here, which is FastAPI.
Yeah.
Right now, Sebastian Ramirez, who is the creator and I think the only person who can accept pull requests, is the maintainer of FastAPI. And this has been raised as an issue. I've raised it with him. I think he's going to bend at some point. I think he has reservations. We saw this in the early days with Django, where there was like this clique of people, of this tiny, very insular clique of people. And I think really the ultimate success of Django was based off of that. And that is an issue. And don't have a good answer for it. So I guess I can say is, and maybe I'll change the slide that I will upload, which is governance. So thank you for bringing that up, Calvin.
Yeah.